Okay, so in your kidneys, you have about 1 million of these very small units called nephrons. So this is just a very simplified diagram of a nephron. And what we have in each nephron is we have an artery that carries blood to this thing called the glomerulus. So this artery is referred to as your afferent artery. Okay, and it carries blood to this thing, which is like a ball of capillaries, and this is called the glomerulus. Okay, this ball of capillaries is surrounded by this thing called a Bowman's capsule. Think of it like the ball of capillaries would be like a fist, and this would be like a hand over the fist. So the glomerulus is part of the circulatory system. The Bowman's capsule is part of the excretory system. And what happens is when this afferent artery delivers blood, it's under a really high pressure here, and it forces all of these waste products into the Bowman's capsule. So things like nutrients, that could be glucose, other things like this, salts, water, urea, all gets flushed into this Bowman's capsule. Then it travels through this first part of this tubule, which is called the proximal tubule, which makes sense because it's in close proximity to the Bowman's capsule. The proximal tubule is permeable to a few things like waters and salts, and some of it will get reabsorbed here. So what happens in this first step, because it's like extremely high pressure here, everything gets pushed out of the blood. We force a whole bunch of dissolved substances out. Basically everything except the blood gets pushed into the capsule, which is not always a good thing. We don't necessarily want to get rid of all of the water and salt and nutrients from our blood. So some of it then gets reabsorbed. So our proximal tubule is permeable to water, which is shown right here, as well as salts. Okay, and then it starts descending down this thing called a loop of Henle. And the first part is called the descending part of the loop of Henle. The second portion is the ascending. So the descending loop is permeable to water. So we're still absorbing water here, we're still absorbing salts, and we're still absorbing nutrients. Because we got rid of everything up here, okay, we need to kind of get some of it back to bring us to a nice concentration. When this starts ascending back up the loop of Henle, at this point, the only thing that's permeable is salt. So water is not permeable in this portion of the loop of Henle. But we're still moving salt into the blood, actively and passively. So our salt concentration in our blood is starting to rise now at this point. What happens when you build up a high concentration of salt is that water will naturally want to follow it, but it can't right here because it's not permeable. This last section, which is called the distal tubule, becomes permeable to water again. The only reason it's permeable, though, is because this hormone, ADH, allows these cells to be permeable to water. If we didn't have ADH, water wouldn't be able to move across this membrane, and we would lose a whole bunch of water that would just go right through these collecting ducts, and it would be excreted in the form of urine. So ADH, which stands for antidiuretic hormone, allows us to absorb water so that we're not urinating out excess water. Things that are called diuretics have the opposite effect. So examples of that would be caffeine, alcohol. What they do is they inhibit this water from being absorbed here. So now all of a sudden we've got a bunch of excess water that's just being excreted. So that's why when you drink caffeine or alcohol, you have to pee a lot more, but you're still getting dehydrated because you're not absorbing that water at this last step in the distal tubule.